Okay. During the break, Paul was looking up some other ways to do some. Which one were you trying to do there? Oh, that was just a letter. You were trying to find a code for a letter. Yeah, he was asking me if there was a backslash little l and backslash capital L for letters, and there isn't. My solution for that is this, and Paul's solution was a little more complicated with triple knots, if I remember right. But anything you need, you can find it. Right? And he did find one. It says it looks like a letter, but that's also what this says is any letter. That's another way to do it. You'll find when you do your homework assignment all kinds of lovely regular expressions out there that do all kinds of lovely things, I'm sure. We have a credit card on our form, so let's do the credit card real quick. It should be very similar to all the other ones we've been working on. So in here, I'm going to do 4 digits followed by a dash. So that's 4 digits followed by a dash, or 4, followed by a dash. I want to repeat that 3 times. So there's 4 digits followed by a dash, repeated 3 times, followed by 4 digits, period. Once again, I'm going to do a test. If pattern for credit card number dot test against the string. Thank you. Accepts it, takes one out, doesn't like it. No dashes, doesn't like it. Again, the point is not this is the best way to validate credit cards. The point is this is another way to do validation using patterns. And sometimes they can do things that you just can't get your head around in code. I'm going to skip the zip code and do something a little more intriguing. My notes say copy the hexadecimal pattern, but I don't have a hexadecimal pattern in my notes. So what we want here is some kind of a hexadecimal number. What's a hexadecimal number?
0 through 9, A through F.
0 through 9, or A through F. And so that's really a group, or not a group, but a choice, an in, A through F. Or I guess I could do little, but let's make them do capitals. But that's one hexadecimal digit.
It's got to be 1 or more.
I want 1 or more, which would be
Plus.
plus.
Up to 8. No.
Why? Why can't I have a hexadecimal number that's even bigger than 8 digits long? Oh, because you said so. Okay, well, I said so, no. Okay. Whoa. No errors. Did I forget my knot? No, I got my knot.
He did find.
Okay, my hexadecimal number is not working very well, so I'm going to go put the breakpoint in here. I can find my hexadecimal number. There it is. And let's see if the pointer else, I think I should be getting down to about here. And it didn't go there. So it never got that far. Still don't have a bug error. And so my guess is that one didn't get wired, maybe an onload. Aha! If you knew how many times I've done that, you'd be surprised. Okay, so are you happy now? Okay, got there. So that's a pretty good sign. Let's let it run. Got an error. So yeah, it's not a hexadecimal number. There's that. How come? Oh, they're all lowercase. Duh. That's coming from the pattern match.
If you wanted to allow lowercase, you would just put lowercase a through F in your range.
Yep. Or better yet, take whatever the user did and format it. Make it all uppercase.
Can you format against a regular expression? No,
Let's find out.
Makes sense.
Here's how we do matching. Any number of hexadecimal digits. Remove the ampersand and dollar sign to find a pattern anywhere. Okay, so now what that's demonstrating is if I take this out, I take that out, this says find me one or more A through F's, 0 through 9's, A through F's, anywhere in the string, once. So hopefully that shows you why did that match, because of the E. It found one. There's a hexadecimal number in there someplace. So that's the value of that caret and dollar sign. If you take them out, it's just looking in your string to see if it finds a match for your pattern. Anywhere versus the entire string.
The match returns the pattern.
That one I'm going to have to
Found it out that validation is that.
JavaScript RegEx match. Search the string against the regular expression. Match required. Notice you can do, there is, there's an I. Any guess?
Capital or
Insensitive, case insensitive match, right? So I can take my little a f out of here and simply at the end of my pattern add an I.
So it'll search for either or.
Now it'll search for uppercase, lowercase. It's a case insensitive match. Is that better than the other? Paul's scowling at it. Probably not. I don't know. The other one is a little more clear, right? Because it said give me upper or lower. This is saying give me upper or lower, but it's hidden if you're not watching that eye.
So that goes for the entire.
It goes for the entire pattern. Yep. I don't. If there's a way to do it on the inside, I don't know what it is.
What does G mean?
G means global. And if I was doing a match and not a test, it would find every occurrence of my regular expression, which in this case is a hexadecimal number, and return it as an array that I can then process. But I had another reference someplace I swore that said an array containing matches, one for each, or null if it's not found. Maybe it's in my notes. I'm not there yet. Okay, let's just go over here. If you want to know where the pattern exists, you don't use these because they will match. If you use those, you're saying it's the whole string. Where does it match? The beginning has to. So if you want to know where it occurs, you use search. Right? Not match, not test, but search. And notice this is string comes first. String search for this pattern. It returns the zero-based index of the first occurrence or -1. So you could use search as well as match. So let's do that. If the string ptr.value.search for our pattern equals -1. Then yell at them, else, what was that? I better leave it because I might want it. I'm not sure why. It seems to me that ought to be in the credit card ones. Else, let's just do an alert. But then I've lost it, haven't I? Because I put it up here, I've lost it. So what I should do is create a variable, loc, and that'll be equal to my pattern search. If the loc equals -1, then yell at them. Otherwise, alert found at loc. What do we expect? 4? Zero based, right? Now the other thing to recognize is if I put a G in there, my notes, if I put a G in that pattern, it'll find it more than once. To find all map patterns, come on. I give up. Found array. Okay, find all occurrences. But notice that, oh, this is match again. You add a G to the pattern. So down here I have a G pattern, which includes a G at the end, and it'll find them all, but it's back to match. And I wonder if search will do the same thing. Where was search? Was that up here? Yeah, there's search.
And that's weird that it has to be.
Pardon me?
I find it odd that it has to be in the pattern. I would think that it would be more in the,
That the G would be in there?
that G would be like the search of the match part.
But no, it's in the pattern. Looks like this. It's just like the I that I added before. This finds all occurrences. So if we did a match, we'd have to put them into a variable as well. I hope it's length for the array, not size. Guess I should look it up real quick. Array length, okay. So this will tell me how many it found, because I did a match this time. I didn't spell it right, but that's okay. Still only found one because I still don't have the G in there. Okay, so in my pattern, I can add a G. So they found the E, found the C, found the A. That just told me how many. That's actually an array. We're going to talk about arrays in the next unit in JavaScript. It's not going to take very long, that one either, because arrays in JavaScript are not much more complicated than the collections/arrays we're playing with in other languages. Remember, this course used to be kind of a starter. There wasn't a Swift course in there to review arrays, and so this is kind of the first time we hit arrays hard. Okay. So that's working. Back to the notes. What else? Find all occurrences. So this is an array. Returns an array with 3 elements. Text that matches the pattern. Index of the matching pattern. Really? And this is if you only find it once. So that's where you can find the index. So even if you do a match, it'll return 3 pieces of information. That's interesting. And if we do a global pattern, it returns an array where every element that matched. And they don't overlap. Because if I was looking for 3 digits in a row and I entered 1, 2, 3, 4, I would only get 1 match. Because once it finds a match, it starts at the end of that and keeps going. It doesn't continue from the next character. It continues from the end of the match and looks for more beyond that. Subtle difference. Yep.
So if you run a length while doing a match and it only comes across 1, the length should report 3 because it would have.
No, I think it's a function of whether or not you add the global to the pattern. Okay. Right? If you do a match without a global, and there is a match, you will get 3 pieces of information. That's what the note said. Okay. If there is no match, you get null, which is what we've been doing. That's what we did in that one test where we put in the match to see if it was even there. Okay. But if you put the global in, then you get an array that contains the matches. But that's it. So if you want to know where it was in the string, search did that easy, right? Because didn't search return the where? Seems to me it returned where. Search, yep, returns where. And if you want to know where and what, then you use a regular match. Because at first it shows you the text. Then if you go to another index, it'll tell you where that text was by index number. And then it'll also return the original string, which is interesting. That's one of those I think I would forget real quick, that the match without a global returns 3 pieces of information.
It would be a practical use of something like that possible.
Well, remember, yeah, but remember we're looking for patterns, right? And so if I'm looking for the pattern, I might want to know, okay, I found it, but what was the pattern? Because I said, give me a list of any number of hexadecimal digits. That could have been A, B, C, D, E, F, 1, 2, 3, 4, 5, 6, 7, 8, 9, W, that's the end of it. That entire thing would have been the match, starting at index 17, versus I found an E, invoker's name at position 4. Because when it matched, it would have matched not just the first letter, because we said any number of hexadecimal digits. And so if there had been 17 in a row, it would have given me all 17 of them, and maybe I want that information. Practical use, can't come up with one real quick off the top of my head, but
Thinking like a word search puzzle or something.
maybe. But searching is its own interesting little comment, because maybe I take an array, turn into a string, because there's implode and explode, wrong language, but turn into a string, and then I can just search the string using search for patterns and see how many different occurrences of this occurred in the array. Maybe. Okay, we're near the end here, so let's see what else I got to talk about here real quick. And that's a replace. All right, so let's go back to the credit card one, because I think that makes a little more sense. I don't have an else. What if it matches, and what if I want to format it? Now in here, I could use the replace function. And I ask the user to press dashes. Okay. But what if we said, you know what? Why don't you make that dashes or spaces? For credit card numbers. Okay. And now I should be able to type a credit card number with spaces, but what I want to do here is replace them all. You can use regular expressions to replace. So here this says, in my string, replace the pattern with something new. Okay, so I'll go through and replace all of but I need a pattern. So again, my pattern, what is it that I want to replace? And I have to remember if this replaces in place or if I have to assign it. We'll see. Replace, but I need a pattern. No, I don't. I just put it right in here. I want, and notice there's no dollars because this is looking inside of a string. So you don't put the carets, you don't put the dollars. I want to find a dash. And I want to find that globally. That's my pattern. I could have assigned it to a variable, but I'm embedding it right inside the replace statement. Any one of these, we could have taken this big, huge, ugly string and put it here. Yeah, that would have looked kind of ugly.
Can you do that test after that?
I don't know if it's legal or not. But remember, there was also the other version where the match, where the pattern goes inside the parentheses, there it would go easy. Okay. So here's what I'm searching for. I'm not sure I even need that. But then the backslash. But then what I want to replace it with, that's not what I want. It's the other way around. I want to find a space and replace it with dashes. And I'm almost positive I'm going to have to put that back in the PTR value. No, now's not a good time to lock up. Come on. Firefox doesn't want to come to the front for some reason. What happened to the top of my notepad?
Your full screen on the notepad?
You
Hmm?
have a plus symbol up by the top there.
Whoa. What was that?
Like 10 or something?
Okay, so we went to credit card number, and we said if you put spaces in, that's cool. 1, 2, 3, 4, space. 1, 2. Let's do it again. That's cool. We'll take it. But when we're done, no, it doesn't match the pattern now. Wait a minute. I thought I said add a space.
You did.
I did. Did I save it? I did. Here's my credit card number.
Doesn't match the pattern, so it never gets that.
What's in? It's a space or a dash. 3 times followed by 4 digits. Maybe now that it's inside there with something else around. Remember the dash means here's a range. Maybe it sees a space range and it's not working quite right.
Yeah, it worked for me.
What worked for you? Without the dash? Without the backslash?
Without the backslash.
So that means I didn't refresh very well. Can't count either. Probably doesn't help that I'm putting in 3s. I'm going 1, 2, 3. That's enough. There it goes. And I would just keep going, okay? I believe there's a way, you'll have to do a little research because I don't think I have it here. There's a way to limit it, say only do this 3 times. So you can put a limit on that as well and say if there's any more than that, first of all, it wouldn't match pattern, but if there was any more than that, stop.
Oh, in your pattern, could you just say repeat 3 times?
My pattern says 3 times. You mean in the pattern?
For the replace.
No, because that would change what I'm replacing. If I put a repeat 3 where? Inside here it would say give me 3 spaces.
Or on the outside.
And the 3 it can't go on the outside. The 3 is only an inside thing. The only thing that goes outside are I's and G's.
It'd be interesting to research and
Oh, there's so much more to this.
see how Microsoft does its keys with the 5 characters, and it automatically puts in the dash, and then you 5 more.
Yeah, that wouldn't be real tough now. We're starting to recognize them ourselves, but you're right. Product keys, it puts the dashes in for you, and that could be a placeholder. That could be an access field. Who knows?
Do like some companies do, we just have separate boxes for each section.
Yep. All kinds of ways to do it. Regular expression or a substring. So a regular expression. Oh, that's interesting. At least according to this, which is from the Mozilla Developer Network. You can put in a regular expression or just a string and replace it with a new substring or a function, heaven forbid. Regular expression or a string, new substring, and then flags. What can I put in flags? It's not standard Mozilla. Maybe this isn't JavaScript. JavaScript W3 schools. That sounds more trustworthy. There's my pattern, case insensitive. Another reason for using case insensitive, I want to replace all occurrences of characters. I don't care what their capitalization is. There's a search. Microsoft with W3 schools, Microsoft with W3 schools. Perform multi-line matching. Yeah, I would have sworn, and again, I'm like thinking about how many different languages. I think there's a way, I mean, it may not be in JavaScript, where we can limit the number of times that the search matches. This thing that was yelling at me for patterns is the HTML5 pattern test, uses the same stuff. If we go into the form now and go down to the pattern match, there we define this as a pattern field, the input type. No. Why is this not a pattern? Type can be patterned and then we can match it. I thought that's what I wanted to demonstrate there. Maybe not. Oh my goodness, let's get this day over with. Test pattern. There's a pattern for anything. And if it met, I don't know what the purpose of that one is. Just a generic one, I guess, where you can put in your own and ask if it matches. So that might come in handy when you're doing your homework assignments. Speaking of which, let's take a quick look at what the homework assignment says. I don't believe it's going to be terribly complicated except to use some regular expressions. There is a starter. Nope, wrong one. Dummy, there's no starter. Create a form similar to the one we have in class, so you might steal it. Stevens Point room number, 3 digits followed by an optional capital character. Well, that's what they used to be. Do we have any rooms with letters on them now? I don't think so, but pretend that that's still our room. MSTC course number. Looks like that, right underneath web programming. They all start with 10, by the way. No, yeah, just use that. Student ID number, there's a tough one. MSTC student email address. Think about that one. It's got a little bit tricky pattern. If you need clarification, let me know. And finally, search the web for something useful that we have not demonstrated in class, and don't give me a social security number either. Look for something that might be useful, and I'll share them. Bonus point if you're the only one who finds it. Question? I think that puts you in lab until Thanksgiving. Which
It's
is,
only worth 4 points.
pardon me?
That assignment's only worth 3 points.
Yeah, no, 10 points.
Oh, 2 for
1, 2, 3, 4, and that one.
2, 4, 6, 8, 10.
Who do we appreciate? Never mind. Okay. Done.